So we just learned about the naming and the degree of polynomials. Now we're going to talk about performing operations with them. And we're going to start by talking about sums and differences. Now this one's pretty straightforward, but one thing I want to mention here is that when you're working on a lot of problems, especially if you're taking a comprehensive exam or a long quiz, be sure not to gloss over the problem and mistake something that's written like this for a multiplication problem. Polynomials can be added together. And one of the ways we do that is by grouping like terms. The two polynomials that we're adding together are written in standard form. That means in the order of decreasing exponential value. And what we have is the expression below. So let's combine these like terms and write the result in standard form. So let's combine like terms and solve the problem. As you can see from here, we have two terms with x cubed in them. So let's put those together and bring them down like this. We also have two terms that contain x squared. So we can write them together and bring them down as well. Now we only have one term containing x, so we bring that down. And then we have two constants, a positive 8 and a positive 12. So we can bring those down. So now we've grouped like terms, and we can just go through and perform the operations. So 2x cubed plus 2x cubed is equal to 4x cubed, minus 10x squared plus 12x squared is equal to 2x squared. There's only one term that contains just x, so we bring that down. Then all we have left to do is add the constant, so 8 plus 12 is equal to 20. Let's take a look at a few more examples. We'll do some addition and subtraction of polynomials now. If you'd like, pause the video here and work these out to see what you get, then come back and we'll go over the solutions. If you don't feel like doing that, then just keep watching and we'll go through the solutions right now. So number 1 on the top, we have 4x cubed minus 5x squared plus 2, and to that we add the polynomial 2x cubed plus 3x squared plus 3. There's nothing really complicated going on here, so we can just group like terms as we've done before. If we add 4x cubed to 2x cubed, we get 6x cubed. If we sum negative 5x squared and positive 3x squared, we get negative 2x squared. And then we have the two constants, a positive 2 and a positive 3. If we add those together, we get 5. So the answer we get is 6x cubed minus 2x plus 5. A lot of times you'll get a problem like number 2. You have one polynomial minus another polynomial, and that other polynomial has negative signs in it. My method for working these types of problems is to treat the negative sign between the two polynomials as a negative 1. Then what you can do is distribute that negative 1 across the terms of the second polynomial, multiplying each term by it. So the negative z squared becomes positive, the negative 10z becomes positive as well, and the positive 1 becomes negative. So what we're left with is what you see here, z squared plus 3z minus 2 plus z squared plus 13z minus 1. Now if you combine the like terms here, you get z squared plus z squared is equal to 2z squared. Then plus 3z plus 13z is equal to 16z. And negative 2 minus 1 is equal to negative 3. Sometimes these problems will be written in an odd way. As you can see from number 3 here, it should say subtract in front of the first polynomial. What you'll get is something that says subtract polynomial A from polynomial B. So don't be tricked by this. You're not subtracting polynomial B from polynomial A. You're subtracting A from polynomial B. So in this case, the order does matter. And if you evaluate this, the answer you should arrive at will be negative 7z minus 1. And number 4 is pretty much like number 2, but I thought it worth throwing in an extra problem like that because it's a little more difficult, and you want to make sure working problems like this are second nature to you before going into an exam or quiz. Alright, let's take a break here. When we come back, we'll talk about multiplying polynomials.